All right, so I'm going to be working through this 6.5 exploration in practice 3. Really what this is about is completing the square, which allows us to basically put quadratic functions in vertex form and then find a lot of different characteristics about them. So we were going to do these in a group, and maybe some of you still will, but I know some of you are going to work on this independently. So if it's helpful to go through this video or maybe skip ahead and check your answers, you're more than welcome to do that. So here's our first problem. It says, following quadratic is written in standard form, and that's because it's in the ax squared plus bx plus c form. Use the complete the square method to convert it to vertex form. So to complete the square, the first thing we're going to do is subtract 2, and that should give me y minus 2 equals x squared plus 12x. Now the next thing I'm going to check is my leading coefficient, which is a, 1? Is it just 1x squared instead of 2x squared or 5x squared? And the answer is yes. So I can complete the square normally by dividing 12 by 2, squaring it, and adding it to both sides. That's to make a perfect square trinomial. 12 divided by 2 is 6. 6 squared is 36. I'm going to add 36 to this side and add 36 to this side. I now have a perfect square trinomial on the right, which will factor, and I can write y plus 34 on this side is equal to, and then remember that this always factors to x plus b over 2, which is 6 in this case, squared. Now, just to remind you, if I were to multiply x plus 6 squared out, I would get x squared plus 6x plus 6x plus 36. And that's because this is actually x plus 6 times x plus 6, right? And you'd have to distribute, and you get that. And then you would get x squared plus 12x plus 36. So I'm just confirming here, this is sort of an aside. I'm just confirming that these are in fact equal. Okay, so finally we could write this as y equals x plus 6 squared minus 34. And we're done. We've written it in vertex form. Of course, when you add 6 inside, it shifts it to the left 6. And when you subtract 34, it moves the whole function down 34. So that's just review of completing the square. Okay, scrolling down to problem 2. It's asking us to convert the following quadratics to vertex form using the same method. I'm going to leave this first one, but I will do the second one over here, x squared plus 5x plus 3. Of course, the first thing I'm going to do again is subtract the constant. Then I have x squared plus 5x. Luckily, my leading coefficient is 1, so I can add 2.5 squared to both sides, or 5/2 squared. Right, again, you're always taking this number, dividing it by 2, and then squaring it. That's how you make a perfect square trinomial that can then be factored to a binomial squared. Okay. And so now we're going to simplify both sides. This is going to be y minus 3 plus 5/2 squared is 25/4. And that's going to be equal to x plus 5/2, or 2.5, all squared. That's what that factors to, that perfect square trinomial. This is 25/4, even though it's a little bit hard to see. That's what that says. And so 3 is 12/4. So this is going to end up being y plus 13/4, or 4.25, equals x plus 5/2 all squared. And so we can get y equals x plus 5/2 all squared minus 13/4. And that would be in vertex form. And I'll let you do this one following a very similar method. Move the constant, add b over 2 squared to both sides, factor the perfect square trinomial, and then solve for y. Okay, so we'll move down here to problem 3. Suppose a rocket is shot into the air, rises for a while, and then falls back to Earth. Quadratic function h of t gives the height in meters of the rocket as a function of time in seconds. The equation for the height of the rocket is given below in both standard and vertex form. So this is the same equation right here. The first one, obviously, hopefully, is standard form, ax squared plus bx plus c, or in this case, at squared plus bt plus c. And the second one is in vertex form. Algebraically confirm that these two equations are equal to one another. Show the steps that lead to your answer. So one thing we could do is take the first one and complete the square to get the second one. But probably easier is to take the second one and multiply it out to get the first one. So that's what I'm going to do. I'm going to take the second equation and multiply it out. It says, don't forget the order of operations. So that tells me that I need to do parentheses and exponents first. So there's nothing really to do in the parentheses, so I'm going to do the exponent. I'm going to write this as 4.9 times t minus 7 times t minus 7, because that's t minus 7 squared. And now I'm going to multiply those out. So I've got the 4.9, and now I'm going to distribute, multiplying t minus 7 by t minus 7. So t times t is t squared. Spill the t squared. I don't know. And then t times -7 times t. My handwriting's not great here. So that would be -14t. And then we'd have -7 times -7, which is positive 49 plus 350. Okay, moving over here, we're now going to distribute the -4.9. That would be -4.9t squared. -4.9 times 14, I'm going to assume is a positive 68.6. Pretty sure that's true. And then -4.9 times 49. I don't know what that is, but I'm going to assume when you multiply that and then add 350, you will get 109.9. So it is true that these are equivalent. Great. Okay, so if you want to convert from vertex form to standard form, you can simply distribute and then simplify. Distribute and simplify. Great. Okay. So I'm going to clear this and scroll down. Create a rough sketch of the graph of this function. Use a Zoom whiteboard to insert a screenshot into the group doc. Well, we actually don't have the group doc, but I'm going to just draw it right on here. So -4.9 times t minus 7 squared plus 350. So the thing that I can know here basically, and I'm going to use vertex form, it gives me more information, is that the vertex is at 7, 350. That this thing opens down. The reason I know that is because of the negative out front. And then the 4.9 is going to make it pretty skinny. I also know that the y-intercept is 0, 109.9. So that can give me some information when I am sketching. Okay. So I'm actually going to leave that on there and then scroll down so I can still see that stuff. And so if I create a rough sketch of this, it should look something like this. Let's see. Let's say 7, 350. Here's 7. Vertex is up here. The thing opens down. It crosses at, I don't know, let's say that 110 is around here. And so I get something that looks like, you know, something like this. It's a very rough sketch, right? It should be symmetric across this axis of symmetry, but at least I've got my vertex at 7, 350, and I've got my y-intercept at, really it should be 109.9. And then I'll have another point over here. So that looks pretty good. See, it says from what height was the rocket launched? What characteristic of the graph did you just find? Which equation did you use to find it? Well, launched would be at time 0. So that's right here. That's the y-intercept, right? And so it would be from 109.9 meters. And I would definitely use standard form to find that, because if we scroll up again, you can see that standard form, like I circled there, 109.9. It's easy to plug in 0 for time. these first two disappear and you just end up with 109.9 meters. Could do it with the other one, but easier with this one. Okay. To find out how long it takes for the rocket to hit the ground, algebraically, find out how to do that. What characters of the graph did you just find? Well, hitting the ground should be the x-intercepts or the t-intercepts. Which form of the equation did you use, standard or vertex? Well, I'm going to use vertex. So when you've got basically h of t is equal to negative 4.9 times t minus 7 all squared plus 350, I need to set h of t equal to 0 because I want my height to be 0 when it hits the ground. Now, the tempting thing here is to actually multiply out the t minus 7, but you do not want to do that. Instead, you want to see, what's been done to t and how do I undo those things? So when I look at this, I see, I've subtracted 7, then I squared it, then I multiplied by negative 4.9, then I added 350. So let me undo those things to solve for t. So the first thing I'm going to do is subtract 350. Now I have negative 350 is equal to negative 4.9 times t minus 7 squared. Next, I'm going to divide by negative 4.9. So that's going to give me, I'm going to need a calculator to do that. 350 divided by 4.9, which is 71.428. That equals t minus 7 all squared. Next thing I'm going to do is take a square root. So the square root of 71.428 should be equal to the absolute value of t minus 7. Remember that when you take the square root of something squared, you get the absolute value because it could be positive or negative. So I'm going to find the square root of this and get 8.45. 2 is equal to absolute value t minus 7, which means that either 8.452 is equal to t minus 7 or negative 8.452 is equal to t minus 7. Then I'm going to add 7, and I should get t equals 15.452, or t equals negative 1.452. Well, this is when it hits the ground, right? After 15.452 seconds. And it says explain why it makes sense to have only one question realistically, even when you get two answers algebraically. Well, the other one would be like theoretically in the past, right? But if I shoot it from here, it's just going to land over here, whereas the other 0 is in negative time. Okay, I'm pretty confident in my answers. So hopefully you can check those with Desmos. And if I'm wrong, you can let me know. Confidence, a little bit dangerous. Suppose we actually fire a rocket off into the air. What characteristics would be easy to measure? Would this be enough to find an equation? So I'll let you think about that. And finally, the last problem, which is problem 4. Skateboarder rides down a half pipe whose shape can be described by the function h of x equals x squared minus 5x plus 8. Assume that h of x represents height above ground in feet and x represents the horizontal distance from the far left side of the half pipe. How high above the ground is the lowest point of the half pipe? Is there something we should do to the equation to make answering this question a bit simpler? Well, if that isn't a leading question, I don't know what is. But yes, I think the answer is yes. We want to find the vertex. So how about we put this in vertex form? So let's do that. I'm going to do that right here. If we have h of x, I'm going to subtract 8. And that's equal to x squared minus 5x. Now I need to add b over 2 squared to both sides, which would be plus 25 fourths plus 25 fourths. Now I have h of x. Let's see, 8 is 32 fourths. So 25 minus 32 fourths would be 7 fourths. 25. So this would be negative minus 7 fourths. is equal to x minus 5/2 all squared. So h of x is equal to, I'll write it with decimals now, x minus 2.5 squared plus 1.75. So now we're in vertex form, and we know that the vertex is at 2.5 comma 1.75. So that's this point. This is 1.75, and this is 2.5. So basically, the bottom of the half pipe is 1.75 feet above the ground, and it is 2.5 feet away from the far left side of the half pipe. So how high above the ground is the lowest point of the half pipe? We just answered that. Should be 1.75 feet above the ground, which is what you'd want to write down. Okay, I'm going to clear all this and scroll down. How far horizontally is the skateboarder from where she started when she is 4 feet above the ground? Okay, so 4 feet above the ground, we need to ask ourselves the question, is that an x value or an h of x value? That's an h of x value. So that basically means that we need to plug that in for h of x and then solve. And I'm going to use vertex form. So 4 is equal to x minus 2.5 all squared minus 1.75. Actually, it was plus. So let's see if we can solve this equation. I'm going to subtract 1.75. Again, I set my equation equal to 4 because we're wondering when she is 4 feet above the ground. Minus 1.75. So 4 minus 1.75 is 2.25. And that is equal to x minus 2.5 squared. Now 2.25 is, what is that, 9/4? So I'm going to rewrite that as 9/4 equals x minus 2.5 squared. And now I'm going to take the square root of both sides, and that should give me 3/2, which is the square root of 9/4, equals the absolute value of x minus 2.5. And that means that either 1.5 equals x minus 2.5 or negative 1.5 equals x minus 2.5. And so adding 2.5, we should get 4 equals x or 1 equals x. So she is either 1 foot or 4 feet away from where she started when she's 4 feet off the ground. And if we scroll up here, we should see that there are 2 places, right, where she's going to be 4 feet above the ground. There's going to be one right there at x equals 1 and one right there at x equals 4. And that does it. So hope that was helpful.